Hello there, viewers. Name is Ryan Shimeen, and today I'll be talking about my additive and subtractive synthesis that I was working with in Max MSP. I was working in version 6, as you can see, and this is the basic patch, and it's mostly complete, yeah. And you can see some of the labels are already in, and everything is in there. So just to get it playing, so you can hear the sawtooth wave that's on default setting. So just turn on the trigger, and that's the SDAC. And SDAC works as a user interface version of the DAC twiddle object. It appears as a button which can be clicked with a mouse to turn audio on or off. So if I were to turn off the trigger here, you won't get to hear the intervals. It'll just be one monotone, continual sound. There you go. I've turned it back on. You can hear the interval is back on with this number here that determines it. So, stop it for now. Well, to define these objects here, we can understand what they're all about. We'll look at the presentation mode first. You can see it's ordered, but not quite too ordered in a way that I would probably like. But it's good enough. It's good enough for now. And go back to the patching mode. And here you've got an aux patch. If you double click on that, you can see the aux subpatch which is in there. You see sends and receive, which are both in. Alright then, so to define these objects, well, usually if you want to know what an object does, you can just press Alt and click on the object. That's if you're unlocked first, obviously. So let's click on the object. So is an anti-aliased sawtooth oscillator. You use the saw twiddle object to generate an anti-aliased sawtooth wave. So there's a definition, sawtooth with a value in there, an argument, and yeah, it's a basic definition of it. And yeah, basically it works that simple. And obviously, since I'm focused on additive synthesis and subtractive synthesis, it's best to define them, what they actually are. What is additive synthesis? Well, let me put it simply. Additive synthesis is a sound generation technique that combines simple waveforms at various frequencies and amplitudes to create more complex composite waveforms. Some of you might be familiar with the Fourier theorem, which is Fourier theorem, and that would definitely help in explaining what additive synthesis actually is. And as for subtractive synthesis is also sometimes called analog synthesis, which is when you start with a sound and then you subtract all the unwanted bits in that sound and then control its loudness over time. So basically, subtractive synthesis, there's 3 stages. You come from an oscillator, which in this case is a sawtooth wave twiddle, and then you go to a filter, and then you go to an amplifier. So those are the basic steps that define what subtractive synthesis actually is. What a filter does, well, a filter is in this case, this message, it's used to cut off or cut down the brightness of something more into something more subtle or something more suitable. This resultant sound is routed to an amplifier, which is already in the patch as well. So, yep, that's a definition of a filter object. And here, a metronome acts as a metronome. Metro acts as a metronome which outputs bangs at regular specified intervals. Well, the object uses the max time format syntax. And here we've got star twiddle, Star twiddle. Well, this star twiddle is a signal multiplier operator that outputs a signal, which is the multiplication between two signals. That's the basic definition of it. So, in other words, it's a signal multiplier implements an amplitude envelope. And the other symbol, the plus twiddle is an add signal. Any signal, the plus twiddle object is necessary only to show signal addition explicitly, or to add a float or int offset to a signal. The plus twiddle object is necessary only to show signal addition explicitly, or to add a float or int offset to a signal. And what else have I left out for now? Well, you can right click on some of these objects and they can, if you click on the top help, it'll define you what it actually is. So as for this scope object, scope is simply a signal oscilloscope that allows you to monitor the visual progression of an input signal's waveform. Unlike a physical oscilloscope, it is resizable. Here we've got a spectroscope, which is that object here. And the spectroscope twiddle serves as a visual spectrogram or sonogram that interface for the analysis of signals. And as you can see here, you've got cycle twiddle numbers that go up from 50 to 100, 200, all the way up to 1,000. You can see regular intervals. You can add more if you want to. As an example, you can add 600, 700, going up, and so on and so on. These are just values that determine how much you can actually go up in terms of additive synthesis, which is going either up positive or negative. Example, if I turn on the trigger now, or if I lock the patch first, I turn on the trigger and then play the sound. If I push this down, you get some really bassy. The more bassy it gets, as you can see, if you go up, and if you go into the negative, but if you go to one other side of the end, you get more higher frequencies. As you go up and down, you see it's higher frequencies. And of course, well, let's stop this for a while. You can order this even further if you want to. For example, if you unlock that, well, this can just press Command Y to order it for you. You see, it's straight into up. and here as well, Command Y after you highlight both of them, and so on. I'll leave these for now, or before I complicate things even further. But even that, I can press Command Y, I can order it. Or not in that way, obviously. Perhaps there, yeah, that would do. That's a good thing about Max version 6. You can order it automatically sometimes. You don't have to press Command Y. And yeah, if you go presentation mode as well, effect is the same. If you turn on, well, lock the device first and turn on the object, turn on the trigger, and then play. Get more bassy sound here. Stop this for now. Let me change the color of these actually. Change the color, make it bluish, just to know the separation is. And yeah, so that means it'll also be blue back in here. You can see this one's the odd one out. You need to know which one's which, you know, these numbers, because they're not labeled yet, so you have to know which one's which. So that one's the 1, which is over there. Back into the Max 6 patch to get some of these functions playing the way I want them to. Well, obviously this one connects to all 5 of them, all the way from cycle 100 to cycle twiddle 500, and cycle twiddle 1000 is completely on its own. That's where you get the high frequency, sort of like high amplitude sound that you got there when I played it. So just to play it again, put the interval on it. You can see. Yeah, definitely high into it. And this one changes all of these at once. The same value, exact value you get here is the same value you get in all these 5. Go back to 0. This is for odd. And for even harmonics, so that's another feature. Let's stop that.